Hi, welcome to Offline GraphQL Apps with AWS App Sync. My name is Karthik Saligrama. I'm a software development engineer with AWS Mobile, specifically the AWS App Sync team. So what are we doing today? We're going to talk a little bit about what is GraphQL and what are some of benefits of using GraphQL. Then we're going to touch a little bit about AWS App Sync, which is a managed GraphQL service. We're going to talk about the new features that we launched a couple of weeks back. And then we're going to dive into offline application development and how AWS App Sync helps you develop applications offline very easily. Finally, we're going to finish it off with a couple of demos. So we're going to do a iOS Swift app demo. So let's start off with what are a couple of offline real-time use cases that you see in the world today. So there are a couple of use cases where the users expect the data to be available offline, something like financial transactions. So if you want a history of your banking transactions, news articles, especially if I want to read something while I'm like traveling in subway where there's like intermittent network loss, single player games, messaging apps where I'm posting a chat message to some of my friends or a group, and I don't have network connectivity. I want the messages to be queued up. Document collaboration is also another interesting case where I'm sharing Word docs with multiple users, but I would like to make edits even when I'm not connected to network. On the flip side, there are some use cases where the users expect the data to be available immediately. For example, banking alerts. So let's say there's like a fraudulent transaction. You want to notify your customers almost immediately. News stories, like if there's like a breaking news, you would want to broadcast it as soon as possible. Multiplayer games, if I'm playing some game with my friends, I want to know what is the current state of the gameplay for my friends. Continuing on the chat scenario where if I'm sending a message and I'm online, I would like to notify my friends or the group of my friends immediately. Shared whiteboards, document collaboration, and even the new AR/VR experiences is some of the real-time use cases. So if you observe, there's like some sort of a trend here where we're saying that almost where users expect the data to be available immediately, and apps where the users expect the data to be available offline, there's like a sort of there can be cases where there's like almost zero transition between the two. So let's dive into what is GraphQL and see how AWS App Sync and GraphQL help you achieve these use cases. So what is GraphQL? GraphQL is an application query language. It is agnostic to the underlying data store, which means that you can pretty much wrap a GraphQL query or a mutation on top of any database that you have, whether it's a Amazon DynamoDB table, Amazon Elasticsearch instance, or Amazon Aurora, a Lambda function, RDS instances, many more. It's important to note that it is not a database by itself, and it's definitely not a graph database. And the most important part about GraphQL is it's optimized for performance and flexibility and client-side development. So how does GraphQL really work? So you start off by modeling your application data in something called as a schema definition language. The GraphQL schema definition has a type system, so you define your model as within the type systems. This is an example of a type of a GraphQL schema. Now, the user or the client would run a query against the schema by making a call via an HTTP or any other transport mechanism. And the server sends a response, and notice that only the data that is requested by the client gets returned back to the user. Excuse me. What are some of the benefits of GraphQL? So if you're aware about how you want to model your data, the amount of effort that is actually required from prototyping and iterating over it to actually make a call to fetch some data from your data store is very, very fast. Another important part about GraphQL is introspection support. So traditionally, if you're using something like a REST API, you would want to publish updates to your definition of your API by publishing something like a Swagger document or something that is equivalent to it. But with GraphQL, every time you iterate over your API, the changes automatically gets published to the client, or rather the client can see what are the new changes to your schema. It's emphasized with client performance first. So what this means is that, and we're going to touch a little bit of examples here. So let's say that you are sending one of the important features with GraphQL is partial data support. So you can request only information that you would like to render on the client. In traditional REST RPC world, you would do this by actually adding filters to your post call. And there are a couple of other design patterns that we'll talk about. But even with this scenario, you almost always end up in REST RPC sending a lot more information and consume more bandwidth as compared to a GraphQL call. Continuing on how it delegates power to client, let's say that you have an Uber Post API that kind of like gives you ID, title, comments, images, authors, and bio of the author and things like that. But if you want to expand this Post app to like different clients where you're consuming less amount of data, for example, if you have an iOS app that only shows a list of all the posts, you might want to just display the title to so that the user can browse through it. Now, in order to make it performant, you might just have a separate API that just returns the title. So you have a branching of posts where you're doing posts with just title. Now, if I have more real estate on my user interface, I might also include author information. So I would have a new API again, which says post with title and author, and so on. So I might include content, I might include images, I might include comments. So you can see that this gets a little messy and it might be very difficult to maintain. But with GraphQL, you always have a single endpoint that is /GraphQL. And between the clients, you can start off by just saying post with title and author, and then you can just, if your client has more real estate, add additional fields in the request body by just specifying, in this particular case, content. You can have pagination as a property of the request, or you can expand on the author where you're requesting the first name, last name, and the image URL. And you can even go so on and say that I want the image of the author to be of 80 pixels or something, and also request content and comments and things like that. So the important point over here is that between the first call where I'm requesting only title and author to all the way at the end where I'm requesting a lot more information, the decision is always made by the client, and there is almost zero change on the server, except for modeling the data as required. So the client makes a decision as to what it needs to request from the service. Now, one important factor with using filters in the REST RPC world is that at some point it might get a lot more cumbersome. So if you're using include with title and authors, and you have nested fields, or you have a lot of nesting in your query, you might have to use dot notation and things like that to specify all the included parameters that you want to return from the REST API. But with so the alternative to this is hypermedia or HATOS, where you might, if you have a really nested stuff query, you can return links to the in this particular case, the author is returning links to get more information. So the client now makes calls to the links that is specified in the response in order to get more information. But let's say that you have like a post that returns 20 items, and each item has authors that's like 2 authors to each of the posts. You will be at least making 21 calls to your backend. But with GraphQL, by intelligently modeling your schema, you can basically just have a single API call that returns all the information that is required for the client to render its user interface. And the differentiation, the choice to the design choice where the developer has to make between exposing include headers or endpoints is completely gone. So what is AWS App Sync? AWS App Sync is a managed service for application data using GraphQL. It has emphasis on offline programming model and has real-time capabilities. In addition to this, it has flexible database option. So today we support Amazon DynamoDB, Amazon Elasticsearch, and AWS Lambda function. So you can wire these data sources to your GraphQL fields. In addition to this, we support authorization mechanisms. So we have AWS IAM-based authorization, API key-based authorization, and OpenID authorization using Cognito user pools. Now, the authorization is both coarse-grained and fine-grained, so you can specify whether a group has an access to a particular field, or if a user has access to a particular data. And we're going to talk a little bit more about it as we go on. So how does AppSync really work? You start off by creating a schema definition language, and you can upload that schema to your GraphQL endpoint using the CLI or AWS console or one of the AWS SDKs that we support today. Then you would start off by creating data sources. Now, the data source is basically a combination of your underlying data store and a credential that AppSync is gonna use to assume in order to make calls to your resource, like a DynamoDB table or an Elasticsearch instance or a Lambda function. Now, once you have your data store and your schema, you can wire up the fields in the types of your schema to a data source by something called as resolvers. In addition to defining these, you can also define subscriptions that allow you to get real-time application data. And you can use the client SDKs that come with it today to fetch the latest information from the service. So we touched a little bit about how what a resolver is, but how does it actually work in practice? So a resolver basically has 2 parts to it: a request mapping template and a response mapping template, and it works with a data source. So when a request comes to a graph, when a query is made by the client, the AppSync service figures out what are the resolvers associated with the query and what is the data source associated with that resolvers. And as a field is being resolved, as the field value is being figured out, what AppSync does is it tries to parse a request template. A request template is basically a velocity template that allows the AppSync service to make a call to your underlying data store. So it tells AppSync how you can interact with your underlying database. So for example, if you want to make a DynamoDB put item call or a get item or a query or scan or any other operation that we support today, you can specify that in your request mapping template. Similarly, you can specify whether you want to do a search function or a get item on a individual index on an Elasticsearch instance, or you can also do a invoke or a batch invoke on an AWS Lambda function. Once you get a return return message from your backend, response template, which is again a velocity template language, is run, which basically parses the response against the velocity template that is specified. So this allows you to have custom logic, like, authorization post, like requesting the data, or it could also be like, filtering out information that is only needed to be displayed, that is only requested by the client. Recently, we launched ability to mock velocity templates. So this helps you in your debug flows. So let's say that you have a put item DynamoDB call. You can create a mock context object that allows you to mock the data that is being mock the context that is going to be run against the velocity template, and this allows you to, without actually making a call to your underlying data store, allows you to see how the velocity template is going to function, and we're going to see a demo of this shortly. Another important feature that we recently launched is the support for Amazon CloudWatch logs. So as you are running the GraphQL query, you can optionally specify whether you want to log the information to Amazon CloudWatch logs. And AWS App Sync logs the request header, the request body, also field level information, and you can specify the granularity of the information that you want. So, or you can just turn it off, and also the response headers that was sent across the wire. So this gives you a lot of information about how the data is flowing when a client makes a call to the AppSync service. So let's quickly run through a demo of how this works. So I have a Photos API, that GraphQL API endpoint that I have created. It has Cognito user pools authentication mode, and this is my GraphQL API endpoint. It's in US West 2 region. I have a schema that is associated with my Photos app. So I have basically mutations and queries. So if you look at the mutation, I have something called as track sign-in, which allows me to figure out track users when they log in for the first time on the app. I also have a create post API that takes a post metadata and an S3 object. I have an upvote function. I have post comment that allows me to comment on particular posts. Similarly, I have queries, which allows me to list posts or list comments or list people who have liked. Now, in addition to this, I have supporting data structures over here, which I've defined as types. So I have a type post, which basically has an ID, author, description, location, likes, counts, and things like that. All the information that I want to display in my user interface. Now, in addition to this, I have a type called S3 object. This allows me to upload information to an S3 bucket, where the bucket and key and region are specified. I also have a user object that captures the Cognito user pool subject and the username from the JWT token when I track sign in. So let's quickly look at the resolvers. So I have a couple of resolvers over here. So for track sign in, I have a user stable resolver. Now, before I quickly jump to resolvers, I just want to show you data sources. So I have 4 DynamoDB tables and 2 none data sources. So these represent individual DynamoDB tables that AppSync is going to interact with in your AWS account. Now back to my schema. If I filter out the mutation and go to my users table, what I'm doing over here is I'm making a DynamoDB put item call to the users table. Now, this DynamoDB table has a hash key of subject, and optionally I'm adding attributes username and last login. In the response, I'm just passing back whatever is the result that I got from DynamoDB. So I'm just passing through it and representing it as JSON. Now, if I were to actually test how this request and response mapping template functions, I can optionally set up a context objects, and I've set up a track sign-in context over here. So let me go ahead and create a new one for the demo. So I can create a new sign-in context, and because I'm using Cognito user pool auth, I'm marking the result and arguments and everything. So I'm going to say subject as 1, 2, 3, 4, username as Nadia, identity again as 1, 2, 3, 4, and username as Nadia. So I'm going to save this, and I'm going to use the sign-in context to test my request and response mapping. So what I got was, after the test context was run against these templates, I got the subject, I got the lost login time, which is actually a function that returns the epoch milliseconds, the current time in epoch milliseconds. And I also got the evaluated response mapping template. So this looks all good. So I can go ahead and proceed with actually making a call to my GraphQL endpoint. Now, similarly, I have also wired up resolvers for all the other fields. So I have a create post where I'm doing a put item on a post data source, post table. I also have likes count, which basically gets me the count of the number of likes for a particular post. I have comments count. I have people who have liked, which is basically a list of people who have liked. And I have an S3 image where basically I'm serializing the bucket key and region to a DynamoDB table. Similarly, in my queries, I have a list post call that returns me a paginated list of posts in from my post table. Now let's go ahead and try to fetch some results. So I have a query called list post. Let me try to write it up from scratch. So I'm going to log in with my Cognito user pool app client ID. I'm going to go and use this photo app user pool. I'm going to fetch the app client ID, and I'm going to log in with this client ID and pass in a username and password that I created for this demo. Great. So now I have logged in, and I should be able to see the docs. Great. So now I can start typing in my queries. So I'm going to pass the max result as 2. I want to list all the posts. I want the ID. I want the author. I want the subject. I want the username. I also want like the image. So I want the bucket key region. Great. So I'm going to run this query, and let's see what happens. So you'll see that it fetched the data from my DynamoDB table, and it's basically returning all my posts with my author information for my post, and also the image file associated with my photo. Now, additionally, I'm also fetching logs from CloudWatch. So when I made a call, it started pushing logs to CloudWatch because I have configured my API to publish logs to CloudWatch. So I have request headers in my logs. I have the GraphQL query that was run, and for each of the resolvers that was run, I have the mapping template. I have what was the resolver on. I had the transform template. I had the context object. I have whatever is the result that was populated. And I also have more fields over here for like S3 and object for the image field. And you can try to want to opt out if you want to opt out of the granularity of logs per individual fields. You can just simply go to your settings and scroll down to logging section and either disable logs if you don't want them, or you can set the granularity of field level logs to just say something like error. So like only in case of a field error, the logs will be logged to CloudWatch, or you can just set it to none, in which case we're only going to be logging request and response headers. So let's get back to our presentation. One thing that I did not talk about is with AWS AppSync, you can actually mix and match data sources. So if you had a query where you want to do a free text search for search post, and you felt like Amazon Elasticsearch is a better fit for your use case, you can, for the search post field, you can route the calls to Elasticsearch while still routing calls for to Amazon DynamoDB for add post and list post field. And AppSync allows you to do that out of box. Let's quickly jump to the client side of things. So when you're developing apps for offline, what are some of the offline application considerations? So if your application has a lot of local storage, like if your application has a lot of data transfer between the service and the client, you might want to have local storage options. And this can be like a file storage, or it can be a SQLite, or it can just be local storage in case of like React or React Native apps. And you might want to decide whether you want to just have read on the local storage or write. The choice is really up to you. Next, what you want to do is you want to maintain an order of operations. This is really crucial, especially if you are supporting offline mutations. So if I have, for example, a chat application where I'm sending messages, you want to ensure that the order of the messages is that the user is sending is sort of retained somehow. This is important because otherwise it won't, to the user who's receiving those messages, it might not make sense. Network state management is also crucial. So let's say that I am working on an app that is online, and suddenly I transition to an offline state because of loss of network. You want to handle that transition gracefully so that the user's app does not crash or doesn't lead to a poor experience while using your app. Another important factor for offline consideration is UI updates, and specifically optimistic UI updates. So let's say that you're allowing offline mutations. You have a screen that is doing offline mutation, and you have another screen that is actually fetching similar data or the same data from for like displaying like a list of those data types. Then you might want to show the list to be an updated list that includes the offline mutated data. So this is called as optimistic UI update, and we're going to talk about a little bit more about it in our another demo that we're showing for Swift. An advanced scenario for offline application is conflict resolution. So let's say super important if you want to have shared offline experiences. So like, for example, document collaboration and things like that. You want to ensure that if users are working on the document at multiple modes, network modes, you're handling that more gracefully. So currently, with the AWS mobile SDKs and the AWS AppSync service supports all the previous use cases that I just mentioned, in addition to supporting things like subscriptions. So we support Android, and this includes Java and Kotlin, Swift or iOS on Swift, React and React Native applications. And users can choose to develop in one of these platforms. It is built on top of the popular Apollo GraphQL specs. So we built on, we're already using the best practices from Apollo GraphQL and extending that to support more use cases for offline and real-time capabilities. How would you use the AWS mobile SDKs? So you would start off by configuring your AppSync client by specifying an endpoint, or AWS region, a user pool auth provider that allows me to get a latest token, and optionally an S3 object manager. So this allows the S3 object manager is basically to transfer data, upload and download data to S3. You would do the same thing for Android, and this is Kotlin sample, but it's extendable to Java very easily. You would specify the application context, the user pool auth provider, the AWS region, and the service URL. Now, in order to perform a simple mutation, what a client has to do is create a new sign-in mutation. And these objects, the sign-in mutation object is auto-generated for you by the SDK clients. So we have a code generator that is run, that you can run whenever you make a changes to your schema or your query itself, or query or mutation itself. And the code generator basically generates POCOs of POCO representation of your GraphQL query or mutation. And once you have that, you can use these POCO objects to perform a mutation and then get a callback result or an error object. And this is the same across both Android and iOS, really. Now let's dive a little deeper into offline mutations. So let's say that Jane is creating a new document. She's created a version 1 of the document, and she's online. But because of poor network connectivity, she chooses to start working in an offline mode, and she has a version 2, which is updated document. At the same time, John is working on a version 2 of the document based on Jane's version 1. And he also makes version 3 of the document, which is based on version 2 of John's. Now, when Jane comes back online, the expectations from most customers is that you are somehow resolving any conflicts that might occur when Jane comes back online. So, and this might either be handled, this might either be a way by giving Jane an option to resolve the conflict herself, or the server automatically does that for you. So how does AWS App Sync help you with such a use case? So we support conflict resolution in 2 places. One is conflict resolution on the cloud, and optionally a conflict resolution on the client. There are 3 strategies for conflict resolution when you're specifying a conflict resolution on the cloud. The first one is server always wins strategy, where you're basically saying, I'm going to ignore whatever data that the client sent to me, and I'm going to just assume that the data that is on my service is always right. The second one is silent reject, where this is a special case of server wins, where I'm saying that I'm going to make my clients think that that they have won, but it's actually the server data that I'm going to respond back with. Then you can choose to have a custom logic, and you can choose to use an AWS Lambda function to basically have a business logic that can extend and have your own custom checks around how to resolve the conflict. And as I mentioned, you can have a dummy conflict client callback that kind of does that just on the on the user side, and give a user a way to resolve the conflicts by themselves. So how would you do something like this? So let's say that you have a DynamoDB put item call. Now, in order to check for conflicts, you would write a conditional expression. So in this case, you can extend based on DynamoDB's conditional expression to check if an attribute exists or not. And based on whether the attributes exist or not, you can specify a conflict resolution strategy on the request mapping template. So in this case, if I have attribute not exist, I can specify a custom strategy. I'm specifying a custom strategy, and I'm specifying a Lambda function to invoke whenever the condition check failed occurs. So this allows me to kind of, and I can change the strategy from custom to like server wins or silent rejects. And this allows me to have conflict resolution on the cloud. Now, one of the things about GraphQL is that the response type is always application JSON. So how would you transfer images and rich media? So in order to do that, we support a special type called as S3 object and S3 object input. The AWS mobile SDK client generator is aware of this type and allows you to generate wrapper S3 upload and download methods that you can use to transfer data to S3 and also store the metadata information in your DynamoDB client or Elasticsearch function, or pass that to a Lambda Elasticsearch endpoint, or pass that function, pass that information to your Lambda function. Excuse me. And you can reference this S3 object type in your regular types like a profile pic, or you can also use the S3 object input in your mutation as displayed on the screen. Next thing is about GraphQL subscriptions. So what are GraphQL subscriptions? So they are a mechanism by which you can transfer real-time updates to your backend, from your backend to your client. With AWS App Sync, this subscription is event-based mode, and it's triggered by mutation. What this means is that whenever a mutation occurs, you can associate a subscription operation to that mutation. And this allows you to scale to any data source. So you can have a subscription to a Lambda function as a data source, or a DynamoDB table as a data source, or an Elasticsearch endpoint as a data source, and it's super scalable. How would you achieve this? Using schema directives. So if I have a type subscription where I have added post, and I have a type mutation that has add post, and I wish to associate my add post to my added post subscription, I would basically have an AWS subscribe directive with a list of mutations that is pointing to my mutations that I wish to trigger this subscription. So when a client makes an added post subscription call, I can, the service returns whenever a mutation occurs. Whenever an add post mutation occurs, the added post subscription gets triggered, and any client that is listening to the changes for added post gets notified. Now let's quickly jump to another demo for an iOS app. So I have an iPhone app that I have set up for the same schema that I had shown a couple of minutes ago. I have it wired up with Cognito Auth SDK and AWS App Sync SDK and the AWS S3 SDK. And in addition to this, I have downloaded my schema JSON from this link in the console. So if you go to the schemas, and you can export your schema JSON from this link. So once I've got this, and I start creating the list of operations that I want to write in my app. So in my case, I am using track sign-in, so to track when a user logs in for the first time. I want to do a list post, so I can track a list of, I can track all the posts that are created by different users. And I'm also doing create posts, which allows me to create new posts. Now, once I use the code generator to generate the object representation, I get an API.swift file over here, which is basically a object representation of the same queries and mutations that I created in my GraphQL file. So this allows me to sort of interact with Swift, program in Swift more easily and like in a more friendly manner, as opposed to writing GraphQL queries natively. So let's quickly jump to my app. I have a Photos app that is currently running on my device. I have two photos that is already created for my application, and as you can see, the phone is in online mode, so the Wi-Fi is enabled over here. Now, with let's see how this is wired up. So I have a clients.swift file where I am maintaining all the SDK clients that I am going to use within my app. So within this function in my init call, I have a credential provider that I'm setting up in order to use the Cognito user pool JWT token to federate into Cognito federated identities, so that I can log in, I can make calls to S3. At the same time, I also have an AWS AppSync config and this interface, client interface, also implements a user pool auth provider protocol, which allows me to get a JWT token, that is the access token, in order to actually access my GraphQL endpoint. Now, I use the AWS Service Manager to set a default service configuration. So whenever I do something like AWS S3 transfer utility.default, it gets the credential provider that I have set up over here. And I have get latest token, which is the protocol for user pool auth provider, which basically returns the latest access token, as you can see over here. And I also have the logins map implemented that returns the Cognito user pool ID token along with the key for Cognito user pool. Now, I have a register function that is basically called when the user logs in for the first time. So I am going to do a simple perform mutation for track sign in, and I'm just going to call the callback. In the list post, what I'm doing is when my view loads, I am using the helper to register my client. So this allows me to actually call the register function that I just showed a couple of seconds ago. And once the register function succeeds, I'm going to call load posts. The load post is basically what it's going to do is it's going to make a call to my AppSync, but it's going to fetch the cached data from my server, from my local storage. So it's not going to make a network call at all. So it's going to return whatever is the data that is stored in my cache. So when you saw the sample app where I'm returning this list is actually returned from my cache data. Now, when the view appears, I'm also making a network call. So this is just to improve the performance a little bit, and also to help me transition between views. And you're going to see why I did this shortly. So in this particular method, what I'm doing is I'm setting the cache policy to say ignore my cache data and just always fetch from network. And I'm basically appending all the posts if there is like a pagination token available, or if not, I'm just setting all the posts to my array, which I'm using to render my table view. Now in my table view, when I'm getting my table view cell, I am also retrieving the image. So I try to retrieve the image from the disk. So I'm using a utility over here to cache the images. And if the image is not available in my local cache, then what I'm doing is I'm making a call to transfer utility to download the S3 object and basically save that object to my cache and also update the image that you're seeing on the screen. So all in all, let's see how this works with a new post when I wish to create a new post. So when I click on new, I can load some sample images that I have over here, and I can set a location, and I'm going to upload this. So it's uploading, as you can see in the activity indicator. Okay, so it uploaded the image, and as you can see, my load post with network call prefetched all the latest information from my service. Now let's try this in an offline mode. So let's go offline. So I'm going to turn off my Wi-Fi, and just to prove that I'm not connected, I'm going to try to connect. Yeah, so you can see that I'm not able to make any network calls on my browser. So let's try to create a new photo in an offline mode. So I'm going to load another photo. So I'm going to use the screenshot that I have. And I'm not going to set any location because the location uses map kits, which requires the application to be online. And I'm going to upload it. So you will see that the activity indicator just continues to show animate. And this is because what I've done is I'm queued up the image and it's waiting for the network to be available. So I'm going to go ahead and turn on my network. So this should automatically now upload the image. So you can see that the image was uploaded over here. And as soon as the network came back, I also got the latest information. So how does this work with, how does the offline mutation work? So I have a create post view controller that is basically doing the offline mutation. I have an upload image function which is wired up to my upload button. What I'm doing is I am creating a create post mutation. I am also saving the image to a local path. And the create post mutation basically references the image from the local URI and sets the S3 bucket region and the key. So I'm generating a UUID for my key. And basically what I'm doing is I'm performing this mutation. Now, what this AppSync client intelligently does in the background is it figures out that there is an S3 object that is associated with this mutation and first uploads the image to S3 bucket with the key and then performs the mutation to your DynamoDB table. So, and also because my network was not reachable at that time when I had disabled my Wi-Fi connection, what it had done was it had queued up the data in a local queue and processed the data once the network was reachable again. So you can see how AWS AppSync mobile SDKs automatically handle all the offline and the real-time scenarios as I just described in my presentation. So let's talk about some of the best practices for the application. So first of all, don't boil the ocean. You might not want to have optimistic UI updates or offline use cases for every screen of your app. So make a decision as to which of the screens really require offline mutations versus which of them require caching of data and things like that. Use subscriptions appropriately. If you have a large payload size, we do have a limit on the size of the payload, so it might be better off for you to actually just return an event downstream to your subscription call, and then have a query that lazily loads your latest data. This allows you to also paginate the calls whilst not hitting service limits. If you have frequently updating deltas, like for example, like subscriptions, so just try to keep your payload small. Be kind to your customers' battery and CPU. This is super important because the AppSync SDK, if you have a lot of subscriptions, then you might end up having long-lived WebSocket connections to the AppSync service. So it might be draining customers' battery. Other important things to note with subscriptions is the order of delivery is never guaranteed. So make sure that you're handling that on the client. And message duplicates can occur. So you might want to have like a dedupe strategy on your clients. The things to note with conflict resolution is don't overcomplicate it. Model data appropriately. In a lot of cases, it might just be conflict resolution might simply be as easy as just appending the data to the list. If you do have custom cases where you want to handle conflict resolution, you choose to use an AWS Lambda function to handle custom cases, then keep your client logic light. And this is important so that you don't get into race conditions. So scenarios where you are handling conflicts on the client, which triggers a conflict on the server, and this kind of like might lead to race conditions. So you want to keep your custom logic if you're all on one side, either on the service or on the client. And if you're having some conflict resolution on the client, keep the logic really light. So that's it. If you've not registered with the AWS App Sync, I suggest that you hit this URL, https://aws.amazon.com/appsync. And thank you.